Welcome back to another bonus video. Meanwhile, we are having more bonus video than regular videos, but yeah, this is why we are here. I would like to show you everything I know regarding to app hacking, and therefore we might have a lot of bonus content. Alright, in this video over here, we want to exploit the content provider within our own malicious application. So we will perform all three attack vectors, which we have seen in the last video. The first one, the SQL injection. The next one, the path bypass. So the custom permission bypass. And last but not least, we simply ask for this permission and see if the user grants us these. If this is the case, then we can also query the internal passwords of our password safe. Amazing, right? Therefore, let's go. Okay, to write our application, we need our Android Studio. So within Tools, Android Studio bin, here we have it. So let's start this. We are still talking about the Thief application, and yeah, we will start with the SQL injection. So we will write our own content resolver, which is asking the content provider to provide those content in form of those methods, insert, update, query, delete. And then we will use the query method to inject our own SQL syntax. Yes, sounds absolutely complex, but if you have watched the last video where we did all of this in the activity manager, at the end, it wasn't that complex. And within our own application, the approach is still exactly the same. All right, so now let's create a new project. So new project. We choose empty activity because we want to have it as clean as possible. And then let's see, we name this Thief Backup. I guess that's a good application name. Language Java, and I go back to Nougat, but the target build SDK is RP level 30. And there we have to adjust a lot of things. So the whole privacy concept has changed in Android 11 and higher. And therefore I would like to show you all of this. How to write an own application which still can exploit those issues, even on modern smartphones right now. Because later, if we talk about browser and all the stuff, this will not work on modern smartphones anymore. In 2 or 3 years, this will be completely gone. We have to take the new approach over here. And yeah, this is why we are here, right? So therefore, let's move on. Okay, so we go back to Nougat, but we are targeting the version 11. Okay, and now we have to wait until the Gradle process has been finished. So this might take a while, and I will see you in a moment. All right, 1 moment later, we are back. So this one over here, this is our workspace. We've got our main activity, we've got our onCreate method. What's missing? The interaction with the content provider, of course. So how can we interact with this one? Well, if we think back to the theory part, the content provider or the access to the content provider is working in the following way. We have to define a content resolver, and the content resolver is asking the content provider to provide the content. Afterwards, we get back a cursor, which is simply just let's say a pointer into the database entry. So with this cursor, we can access those data. All right? Okay, so how can we do this? Well, it's not that hard, to be honest. We just have to consider some things which has been new in Android 11 regarding to the privacy of an application. And this is also the reason why I would like to show you all the stuff. Because later, if we talk about tools like browser and things like this, those tools won't work anymore in the future. So regarding to newer smartphones, RP level 30 and higher, so Android 11 and higher, there has been a lot of change in the privacy settings, and this will deny access for the browser application, for example. Therefore, we need to know how to do this on our own. And this is why we are here. And yeah, I would suggest let's simply do this for this content provider. So therefore, I would suggest let's simply start over here. So let's start by accessing the password table. The password table is included in the content provider, in the DB content provider, and this one has been exported, so we can simply interact with this one. If we can interact with this one and if everything works, then we can perform our attacks. Our SQL injection, our user permission bypass, and last but not least, what was it? Yes, it's not really an attack, it's simply just asking to give the custom permission. This one over here. Those two. If you're having those two permissions, then we can also access the key table. All right? Okay, but first let's see. How can we interact with the passwords table? This one over here. First of all, we have to get this URI. So this part can be simply copied out of this. and we can include it over here. And so we have to define a new URI, and this is our URI. Okay. And this is our alias to access the password table in the Thief application. All right, so the addressing, easy. But now's the question, how can we create our own content resolver? And this part, it's easier than you think, because there's already a method which is doing everything. So we can simply call get content resolver, here we already have it, and then we can access those methods. We can already see query. Do we also have insert? Yes, insert, update, and things like this. So here we are getting, or we're defining our content resolver in our application. And then we are asking this content provider to provide access to those methods: insert, query, update, and also delete. So these are being defined over here, but we can access them with the content resolver if the application gives us access, which is the case for the password table because this has been exported true. Okay? All right. So therefore, let's see, back to this one. Let's simply access the query method. So query, and here we have now two types of methods. So we've got one with projection, string selection args. This is exactly the one we want to have. And this one, I'm not sure. Query args, cancel, it doesn't matter. We want to have this one. Okay, and now we have to provide all those parameters. I mean, URI, this should be clear, right? URI is our URI. Okay, then we have to define the projection arguments. And this will be later pretty important for our SQL injection, but for now we simply keep it null, which means if we do not provide any projection args, everything from this password table will be selected. All right, we do the same for the selection, also for selection args, and last but not least, also for sort order, yes. Okay. This method is returning back a cursor. So we need to get this cursor. We have to define it over here. Query cursor. Let's import it. And then we are already done. And this is how we can access the data from the Thief passwords table. Amazing, right? Absolutely. So to print this out, we could use it in the following way. System out, print line. And then we can use our query cursor. But here we are now having a little bit of a problem because our query cursor is an object. So it's a cursor object, and therefore we cannot simply print out an object. If we're printing out an object, we simply just get something like add and then this, for example, maybe. So this is just an address. This is the address of this object, but it's not the content. If you want to get the content, we have to use something, I guess it's database utils. Yes, it's database utils. And here we've got, let's see, cursor to string, something like this. Cursor dump, was it dump? Dump cursor, yes, dump cursor to string. So this will take the whole cursor object, everything, every information that's included inside there, and will provide a string for us. So we can save this in a variable, or we can simply print this directly out over here. So query cursor. All right. So this is now everything. We need to access the passwords table and also to print it out in a readable format. All right. Okay, let's see if this works. We use run app. So on the left, we've got a smartphone in API level version 30, and we've got a lot of privacy settings in there. And this might be the reason. Let's see. A lockhead. Yes, if you're searching for system out, nothing is inside here. Let's see. Nope, there's no system out. So our cursor object is not being accessed. And indeed, if we print out this cursor, let's see. Cursor. And let's do this. Okay, I guess the lockhead seems to hang a little bit. Therefore, let's use the ADB lockhead. In case if we are using the ADB shell out of the Android Studio, we cancel the connection from the Android Studio. And yeah, we can simply use it on our own right now. So ADB lockhead, let's see. Okay, I guess we have to search for this. So Let's clean the logcat. And then let's search for system.out. Okay, make this a little bit larger. And let's simply relaunch this app. Yes, we can see the cursor is null. So the whole object is null, which means it seems like we're not having access. And yes, indeed, we are not having access. But now's the question, why do we not have access? Because the Thief application is running on the smartphone and this content provider has been exported. So that's everything we need to know, right? Unfortunately not. Because in Android 11, as already mentioned, there was a huge change regarding to the privacy. So those applications has been automatically locked down a little bit. If you want to interact right now with the Thief application, we need to tell that we are visible for this application. I mean, this is not a big deal because we are the attacker or the attacking application and we want to access the Thief application. So therefore, if we tell the Thief that we are visible for this application right now, we do not lose any sensitive information. But we have to tell this in our application. And this is why I would like to show you all the stuff over here, because if we later take a look at the browser application, those approaches won't work anymore because browser is not aware of the app visibility in Android version 11 and higher. And it won't be because browser will not be supported anymore. And therefore, we need to be able to write our own applications to perform all these tasks. All right? All right. So now's the question, how can we make our application visible for the Thief application? And to be honest, this is also something I need to look up because, yeah, we have to define it in the Android manifest, but I'm not sure about those tags. I guess it's query and the package name, but before we are running in circles, let's simply look this up. So let's see. Okay, so the keywords are Android, app, and visibility. And we can see package visibility in Android 11. Let's see. Okay, changes. Let's see. Packages visible in Android. Okay, here we've got the generic information. Some packages are still visible automatically, might be system applications, not sure. And yes, I guess this is the path we are looking for. So we have to define those queries. Let's see. Yes, okay. Within the Android manifest XML, we have to define this query. Okay, so here we have it. Okay, yes, it's queries. So these are things I cannot remember, but I know that they exist and we can simply look this up. It's not a big deal. And then I guess the other attribute was a package. I even did forgot it. Let's simply take this whole. Okay, so here we have to define the package where we want to be visible for. So therefore it is the Thief application. And we can fetch the information from the package name out of the Android manifest of the Thief application. All right. And this is all right now. Yes, so this should work. Back to the main activity. Let's see if we can make a reconnection with ADB. Okay, so let's see. Let's open a new terminal and then let's restart the ADB server. Okay. So it's being restarted. And now, let's see. Okay, now we can select it over here and then we should have it back. Yes, looks good. Okay, now let's install this application. Over here, we are now printing the query object, so we should get an address, but yeah, we will see that it works if this one is not returning null anymore. So let's install this application. And let's search for system out. Yes, perfect. Cursor, and then we've got this cursor object over here. So here's the address of this cursor object. Nice. So we have now queried the passwords table of the Thief application. All right, let's print out the text because otherwise it would be super lame. Do you still remember how we can do this? How to get out a string out of this cursor object? Of course you do. DB, database utils. Yes, I guess you were right on this one. Okay, database utils and then dump cursor to string. I see it already here. Nice. All right, and let's see if this works. Run. So application is being reinstalled and over here. Perfect, nice. Here we have now all these data. We can see this is our cursor, and here we've got the ID, service, username, password is unprintable. We will deal later with the blob data, and the email. All right, so these are the data out of the content provider from the Sieve application, from the passwords table. Nice, but let's do a little bit of modification because we do not have access to the logcat later on. So therefore, let's print them directly out in our application. So therefore, we just have to make a little bit of an adjustment to the layout. I mean, this is not required right now, but it looks super fancy, and therefore we do this. Alrighty, let's see. Within the resource directory, we've got this layout, activity main layout, and here we've got a text view already in there. We are using this text view to print out this data. I mean, this looks absolutely zero hexolite, and therefore this would be a nice proof of concept or demonstration for the customer. So how can we do this? Well, we go into the code menu, and we have to provide an ID to this one so that we can address it later on in our code. ID, and then ID text view. Yes, okay. So now we've got an ID for this text view, and we can address this text view based on this ID. All right? Okay. Let's also change the background of this application. Android background. And let's make this black. And let's make this text over here. It's not hello world, it is hacking in progress. So that's the text that's normally displayed, but it will be pretty fast overwritten with our data we are fetching from those tables. But nevertheless, let's keep this as some kind of placeholder. And then Android color. And let's take this color. This looks cool. And then also Android text size. 28 dp. This should be good. And I guess we're good to go. Yes, good to go. Maybe let's add some padding, last but not least. Padding left. Let's say 100. Okay, now we are done. Yes, okay. So now let's take this part. So here we are having a text view. We name this text view, and we have to assign this text view within our onCreate method. So within our onCreate method, we are fetching the ID from this text view, and we assign this to this object. So text view, we are typecasting it, and then we are using find view by ID, and now we are using our ID we have provided before. Exactly like this. And then instead of a system out, we are using text view. Set text. Yes. Okay, one last little change. Within the manifest, let's get rid of the action bar on top because this is super annoying. And we can do this in here. Within the theme, we simply delete this part, and then we are using theme design no action bar. Okay, let's install this application and let's see how it looks like. I guess pretty amazing. So those data should be now filled in the text view we have inserted in our layout, or which has been already inserted over there. So our hello world, okay. Yes, we have to do a little bit of an adjustment. The text size is a little bit too large, so let's go down to 20 maybe. And also the padding is a little bit, it's way too high. Close, I would say close. Is it really just something like 14? This sounds so little, but I guess 14 is good. So let's see. Yes, okay, I guess we stick to this one right now. So nevertheless, I mean, it's amazing to see those data from another application on our screen right now. I mean, as an attacker, of course, we do not have to display them on a screen. We could also send them to an HTTP server via HTTPS, of course. So also the attacker should take care about an encrypted connection. And then, yes, we can simply fetch them. So therefore, no physical access for the smartphone would be required. But I guess this is good enough for proof of concept right now. All right, so now let's get back to our attack vector. Yes, let's simply comment this in here. This is query the passwords table verified, it is working. Okay, so let's take this part. And now let's adjust our things. So now what we want to do is the following. We start with the simple bypass, the user's permission bypass. So our application, the Thief application, normally requires those two permissions, but we have seen if we add this one at the end of our URI, then we can simply bypass this permission. So let's do this. And let's fetch this URI. Okay, and let's also describe this over here. All right. I mean, we do not have to change anything beside the URI. This is all. And this should work right now out of the box. Amazing, right? Let's see. We simply run this. And now instead of those password entries, there should be those clear text password and also the PIN. Let's see. Amazing, it works. We've got the password and the PIN. I mean, isn't this crazy? We are opening our own application and it shows the password of another application, of a password safe application. Absolutely right. Okay, but to be honest, I mean, this here was a little bit too easy, right? So simply appending this or also this, yeah, okay, but it works. It works. Okay, this is our first attempt. Yes, of course, afterwards I will share the whole application code for this one. So let's get to our second attempt. And this one is now, what do we want to choose? SQL injection or what's missing? The user's permission. So therefore we have to go for the SQL injection. Okay, so SQL injection. We need to query the passwords table to insert our own SQL statement. The SQL statement will be inserted in the projection. So SQL statement will be inserted via the projection parameter. And we have to figure out what the projection parameter is, but I guess that's not a big deal. So the projection or the SQL syntax is something like select all from passwords, where, and then a bunch of other stuff. And we want to change this to select all from key. Remember, now we are addressing the table name, not the URI scheme. I do not have it anymore. This is the URI scheme. And this one is being referenced via keys, but the table name is simply just key. So therefore in the SQL statement, we directly have to address the key table, not the scheme. Okay? Okay. So we want to have something like select all from key, and then we comment out the rest, which means everything here, which is something like passwords, where, will be simply just ignored. Okay. This means our projection needs to be this path over here. So this path. Okay, and I guess that's all. So this is our attempt, and let's do this. Okay, before we perform our SQL injection, let's see if we can, access data via the projection parameter. So let's simply add a projection parameter, something like this. Because then we are having select all from passwords, and we should get back data. And if this works, then we can play around with this one. All right? Okay, so therefore we want to access the passwords table. And now let's see, what type is this projection parameter? It's a string array. Okay, so therefore we have to define a new string array. We also name this projection new string array, and we can define a new string array in this way. All right, and this is all. Yes, this should work. So if we start this right now, we should get back the same data like we have seen before with the passwords table, because now we are doing nothing different, but we are using our projection parameter in here. Let's see. Yes, okay, works, perfect. So now all we need to do is we need to insert our SQL statement here, which is all from key, and that's all. And this is our SQL injection. So let's see. Whoops, let's run this. It would be also interesting if we're inserting in single quote if we get back the error message, but I guess not. Yes, nice. So we can see this is working. Now we're having our SQL injection via the passwords table into the key table based on a content provider. I mean, wow, it's pretty amazing already. And last but not least, yes, we are now accessing the keys table. Our third attempt is accessing the keys table, and we are using those two permissions. So we are now asking the user to give us these permissions, and if the user grants us these permissions, then we can simply access those data over here. So yeah, let's simply do this, right? Okay, so therefore we are copying those two, or maybe let's define our plan first. So this is the second attempt. Works. My comments are getting less, even farther we go. Whoops, no, okay. And this is now our third attempt, and granting the custom permissions of the Thief application. The things we have to consider are the following. We have to define them in the manifest. Let me think. Yes, I guess we also have to, we have to do the asking. So we need to ask for them during runtime. So this has been included in Android version 6, and it's still common. So there will be this pop-up the first time we are using those permissions. And yeah, if we are not asking, then those permissions won't be granted and we cannot access the content provider. So we definitely have to ask for them. But I guess that's all. Yes, this is all. Okay, so let's do this. Within the manifest, yes, we have to change this. This is the definition of a custom permission. And if you want to use this, we have to use uses permission. Also here, yes. Okay, regarding to this one, I guess we are having trouble because this is Android specific. Label and description needs to be defined in the strings. So we need to create strings for those. I mean, we could use them, or we could also simply delete this. Then I guess there's something like unrecognized. Okay, I will show you both real quick. So in case if you want to define a label, we have to go into strings, which is within values, strings, and then we have to define a new one, string, and then name. And then let's see, let's call this permission description. And then we can insert the text here, yes. And then we can address this in this way. So our label is now, let's see, I already forgot it. Perm description. There we have it. Okay. So yes, here we have deleted it. Here we have created this label. So let's use this label, but I'm not sure if this works anyway in this way. Okay, so now we have the permission included in our application. But if we install this app, it won't be automatically granted. Therefore, we have to ask the user to enable this. And we can do this in the following way. So first, let's get the code. Okay, so yes, we can do it in this way. And we want to query key this way. So this is being protected. Let's see, maybe let's see if this doesn't work, because this should be the case. Yes, the application seems to crash. Let's see. Where do we have it? I guess here. Yes, here we can see our application is the UID 10,124, and it requires to have those permissions. We have set them in the Android manifest, yes, but if we take a look at the application itself, whoops, settings, and we can see 2 has been denied. So these are our 2 permissions, allow editing of the key stuff over here. So those has been denied. Therefore, we have to ask the user to grant us those permissions. And we can do this in the following way. So we need to do this. Oh, let's close this. We need to do this over here before we are starting our content provider interaction. And this can be done in the following way. Oh, let's see if I can remember this. Add combat activity and then, okay, so maybe it is yes, it's activity combat this way. And then a request permission. And here we have now those 3 options. Okay, the first one is our activity. That's easy because this is this object. This is the main activity. And then we are having the string of our permission. Okay, so this is this one over here. Let's simply just take read keys. All right, and then last but not least, there's this request code. I do not remember this anymore, so let's see. Okay, so here we are in the activity combat class. Let's see, permission, request permission, this method. Okay, we've got an activity permission, and here we've got int range from 0 request code. Okay, let's see. Request code, here we have it. Application specific request code to match with the result reported to. Ah, yes, now I remember. Okay, so if we are asking multiple times, then we can keep track on if this permission has been already granted or not. So we can take whatever value we like. It has to be greater or equal to 0. Okay, perfect. So let's get back over here. Let's simply take it's over 9,000. So 9,001. Yes, the permission is, it's a string array. Okay, so let's define a new. I guess we have it already here. So permission, and now let's define new string array, and then we can use this here. Okay, so this should work, I hope so. Let's see. Run. Okay, if the application starts, there should be this pop-up right now because we are directly accessing. Yes, okay. Yes, allow Sieve backup to perform an unknown action. I mean, of course, what could go wrong, right? So let's say allow, and there we have it. Nice. So we can see this one is now the valid entry, even if the path, which has been circumvented in our first attempt, has been set correctly with a regular expression, then we can still use it in this way if we are asking nicely the user to give us those permissions. Okay, I guess it's better if we make a copy of this one because this works and we do not know if our second attempt will work right now, and then we've gotten fallback. Okay. So this is our syntax regarding to querying the passwords table. Okay, so now we've got this problem with this blob value. So let's run this maybe once again. Yes, so here we can perfectly see everything that's in string can be easily printed out within our database utils dump cursor method, but this password is consisting of binary data. And binary data cannot be printed out in this way, and therefore we just have this placeholder unprintable. And for example, if we open a new terminal and we want to print out and carriage return new line this way. If we print this out, then we can see, okay, here are data in there, but we do not know how many and which data. I mean, yes, there might be some new lines and it might be 2 new lines. By the way, if we're using echo without a parameter, it's automatically appending a new line. So if we're using echo with -n, then we can see there's only 1 new line. Okay, so now we know there's a new line character, but how many carriage return do we have? I mean, 1, it could be also 3, could be 4, we do not know. So therefore we cannot print binary data out in this way. What we need to do is we need to encode them, but more to this later. But first let's see how we can get those binary data. So what we want to do is we want to fetch our rows. So here we can see this row ID 0, which means the more entries we've got, the more rows we have. So this is 0, then we might also have 1, 2, 3. It depends on the amount of entries. And we want to go through every entry, and then we want to get all those password blobs over there to store them separately, because then we can use a certain encoding to print them out. All right? Yes, this sounds absolutely complex, and to be honest, this is really heavy Android lifting right now. You do not need to know anything of this. So what we're going to do right now is we are writing this code that you have a reference for this. In case if you need some proof of concept from customer, then you can simply rewatch this video. Otherwise, you can simply just lean back and relax. If this part is interesting for you, perfect. In case if this is overwhelming you, don't worry. After this video, you can completely forget everything you have seen over here, at least regarding to this part right now, because this is absolutely not required to move on in this course. As already mentioned, is a bonus video, and this bonus video is to provide additional information. Not required in this course, but it's simply showing you how to deal with this stuff, which can come handy. Alrighty? Okay. So let's see. Okay, we've got one row ID, which is 0, and here we've got our columns. Underscore ID, service username, password. Alright. So what we need to do right now is, this is our cursor object. And we need to first make sure that we are having a cursor object. So we can do this by checking if the cursor object is not equals null. We have seen if we are not allowed to query this passwords table, then we are getting back null. And the application would fail if we try to move on at this point. So therefore we check if we are having a cursor object. So if our app is visible for the Thief application. And then we're also checking if we're having entries in our database. And we can do this with query cursor, count, get count. Yes, of course, get count. And then we check if it's greater than 0. Okay, so checking if we are having entries in our passwords table. Okay, now we need to make sure when we are reaching the passwords column. So this can be done in the following way. Let's assign an index variable maybe. Index, okay. And our index is now, let's see, our cursor. And then, yes, get column index or throw. And now we say, okay, we want to have the column index of our password column. Because having the index field, which is, let's see, it should be, this one is 0, 1, 2, 3. So it is index 3, but it's the 4th entry because we start counting at 0. So now we have this index field, and this can be used to fetch the data. So we can address this column based on the index, and we can get out the data based on the index. All right. So now we've got this index, and now let's make sure if our index or that the index is greater equals 0, because otherwise we won't have this passwords table, this passwords column. And if this is the case, then we want to get out the data, the blob data. So query cursor, get blob, and here we can see we have now to provide the index, okay. And let's create a new array where we can store those data. So it's a byte array, password blob. Let's also initialize this with 0. Okay. And now, yes, I guess we can try printing it out. I mean, of course, this won't work. Yes, I guess we are getting an address or something like this in there, but we can already see if we are printing this out and how often we are printing this out. Maybe there's a logical error in there, so let's see. Let's rerun this application. Does it crash? I hope not. Okay, it's crashing. Let's see. Okay, the index is out of range. We are not having a typo in there. We are checking it and we are having this. Okay, maybe one thing we need to make sure is that we are at the beginning of our cursor. Is this the problem? Might be. So our cursor has a lot of entries and it depends on the position of the cursor. If we are using query, not sure if it gets to the end. So therefore we need to set the cursor back to the beginning. Yes, cursor stuff is absolutely complicated and this took me a month to understand. It's required in accessing contacts and SMS, for example. So those shady things. Therefore it's maybe good to know, but yeah, it's also a little bit, it's a pain. Okay, so how can we do this? We are using if, and then we are using query cursor, move to first. This is returning back a Boolean value, but it's also setting the cursor to the beginning. I find this absolutely confusing because we are doing two steps and it's not that clear over here. Good rhyme. Okay, so let's take this. I hope this was the mistake. Let's see. Observing everything here. Smartphone locket. Yes, perfect. So yeah, absolutely ridiculous. If you're querying this cursor might be set to the end, and therefore we are trying to access an index which is not available anymore. But now we can see we've got the system out, and here we have now our byte array. Nice, isn't it? Yes, it's just an address, so we cannot do anything with this one. We need to get back the values out of this one. Okay, how can we do this? Well, we've got a nice method for this, and the method is base64. So base64 is an encoding, and this can be used to print out non-printable ASCII characters. As already mentioned, base64 will be heavily used during this course because this is it's a common encoding, and yeah, it's nice to identify, and you can do a bunch of stuff with base64. In case if you're not familiar with base64, then please watch the bonus video regarding to it, because yeah, otherwise this video will be way too long right now. Okay, so let's see. If you want to print out those byte array, we can use base64. Here we already have it. Dot encode to string. Yes, this is exactly the method. So this is taking a byte array as input. Perfect. This is our password blob. And then we're having this flags. But this flags is simply just base64 has some, can be used in different type of encodings. So for example, special characters like underscore are not normally used in the RFC. There's a certain char set, and we simply just tell with the flags we do not do any fancy. We are using the common char set, and we are not providing any additional characters to our encoding. So treat it as normal base64 encoding. And the flag for this one, for this standard value, is 0. Okay, so we are using base64 decode. Now I'm a little bit confused. Oh, sorry, encode to string. We want to encode it. And then password block and 0. 0 is our flags, which is simply just common base64 encoding. All right. So now let's run this and let's see. This should work already. I'm a little bit excited. Nice. Here we have it right now. So our password, which is unprintable, is now being printed out over here. Amazing, right? So we can use this right now to get back those byte values. So if we are echoing this out, this time with dash, whoops. Okay, I'm not sure where this one has been catched. So if you're echoing this with not appending a new line, because we want to print it out exactly as it is. We do not want to append our own characters to this string right now. And then we can use base64 /d, dash d. This is now the output, and we can see why our smartphone is saying unprintable. I mean, what is this? This question mark over here. This one. This one might be new line character. So what's this? We cannot deal with this one, but base64 can. Okay, and now we've got the raw bytes, and to print out or get back the raw bytes in a hexa value, we can use xxd. xxd-p will take those bytes and will give us an hex representation of those bytes. So if we pipe this through xxd-p, then we have finally those raw bytes in there in a nice hexa representation. Amazing, right? Absolutely. So let's append this password also to our output over here. So not only there. Let's see. Okay, let's comment it out over here. And then let's append it to our text. So let's create a new string, output, and this one is right now, let's keep it here. So this is the first part. Oops. So this one is the first part. Okay. And then we are appending our base64. Output, we are appending a new line character, and then password encoded equals, and we append this part. Okay, and then we are simply printing out this. We still got this cursor. All right. So now at the end, there should be this password encoded and this base64 encoded string in there. So let's see. Okay, I mean, we could also directly print out the hex representation, but I guess this is enough Android app development right now. If we're having the ASCII values over there, yes, we have it, perfect. So now we also got this password, which was before unprintable. So by having those, this base64 encoded string, we can simply use this and run it through XXD like we have done it over here. Alrighty. Okay, so this is the end for this video right now, and once again, it escalated pretty quickly. So therefore, let's summarize this real quick. Okay, so afterwards, I will provide you the source code of this application that you have everything. So we did start with simply querying the passwords table within Content Provider. All right, then we have done some crazy Android app development. And over here, those were our attack vectors, the initial idea of this video. So how to interact with a Content Provider and to exploit a Content Provider. The first attempt was, I'm not sure anymore. Yes, it was bypassing the user's permission. Okay. Then we had our SQL injection to access the protected table via the unprotected ones. And last but not least, we added those users' permission into our own application and nicely asked the user to provide us those permissions. In case if the user clicked on this, all the passwords would be gone. So this would be the absolute worst case for the user. And the user just has to click it once. So we can use this as a pop-up over and over again. All right, so this is all for this video right now. All right, so this video once again has become a little bit longer than expected. Sorry for this, but I guess the things we have learned over here, they are really necessary, or they are essential to deal with those stuff. Also newer applications. Otherwise you have to figure this out by yourself, how to deal with app visibility, print out blob data in a Content Provider and things like this. Therefore, I would like to include all the things in this video to show you everything that I know, that you do not have to search it anymore. Alrighty? Okay. In the next one, we will take a look at the path traversal vulnerability, and then I guess we are done afterwards with Content Providers. In case if you have any questions, leave a comment under the video. Otherwise, I'm looking forward to see you in the next one. See you there.